Hello and welcome back to EUMETSAT for the end of week 4 of our online course. I'm really pleased that I'm being joined this week by Hayley Evers-King, co-leader of the course and from the Plymouth Marine Laboratory. Hayley, welcome back to EUMETSAT. It's fantastic to have you here.
Thank you very much.
Here we have a nice example from the end of week exercise looking at chlorophyll around the Italian coastline at the 1 kilometre level. And it's really amazing to me that we can go back to 2003. This data's still there, it's still available, and we can look at it. Looking at some of the questions you've been asking in the forums this week, a lot of you have been reflecting on how much you're enjoying the course and how much you're connecting what you're learning here to the world and our life in the world, which is amazing. We've also had a few questions like this in the forums. People asking, when we do all of this processing to the data and we have a look at these final maps, which look beautiful, how do we know that what we're looking at is still, in effect, true, given so much processing has happened to it? Hayley, do you want to say something about that?
Yeah, I mean, the primary word here to think about is validation. So we're always constantly checking each of these different bits of processing against in situ data that we've taken in the oceans or around the oceans as much as we can, whether that's the atmospheric correction or the chlorophyll algorithms. And using those sorts of methods, we can start looking at where our errors and our uncertainties are. And the previous data we looked at, the OCCCI, is a really nice example of this. They grouped different types of in situ data together to look at different optical water types, so based on the shapes of the ocean colour signal in those waters. And then from that, they were able to apply an error estimation to whole images. So you can see within that map where your areas are more or less uncertain.
So what happens next in this process?
Well, one interesting thing that Murdoch picks up here is about algorithms. So one thing we do often as a community is test lots of algorithms against each other. We call it a round-robin exercise. And this is looking to see which ones perform best. Might be globally, or it might be that some perform better in certain areas, on certain types of water. And we can actually then start merging those together to give you the best possible product over a whole image.
So what are some of the things that are different between an algorithm?
It might be where they're developed. Sometimes they're developed using a specific in situ data set from a specific region, and that water might have a specific type of optical properties, might have a lot of sediment or different types of phytoplankton that live there. So that algorithm then might be most suitable for that type of water.
Yeah.
And you can get very simple algorithms. They can just be sort of simple straight line linear regression between a variable and part of the ocean colour signal. You can also have more complicated ones that are based on whole models from particle level upwards.
And so the differences between these algorithms, you're then able to say which is the best algorithm to use in any one particular place.
Yeah, as long as we've got that in situ data, it's really important that we have that.
And so somebody playing with these or actually looking at the maps at the end, is there a way that they can find what they're actually looking at, find out all the steps that went into making that map?
Yeah, we have good documentation in terms of, they call them these algorithm theoretical basis documents. They give you all the details of the different steps of the processing, the histories of the algorithms and how they're derived. And you can actually then look at the quality of them using the quality flags that are available within the products. So you can load up your image and you can see here, this atmospheric correction wasn't great, or here, that chlorophyll algorithm is out of range. So maybe this isn't the most suitable for my water type.
And that's something we do a lot of here for all of our meteorological data as well, all these theoretical basis documents, the ATBDs we call them. They're all available for people to see and know exactly what's gone into their data. I think it's a really important part of what goes on into science. It kind of helps keep us honest having to publish everything we do. Let's turn now to a new participant in the course. So this is Katerina, who's from Uruguay, who's working on fishing. Now, you've worked with other people involved in fishing. What are some of the applications that she might be able to do with this data?
Fisheries is a great application for this type of data because of the spatial and temporal resolution of it. We can really start looking at what's going on in the water, why you might fish in certain areas. And what's interesting here is Katerina picks up two different types of data, chlorophyll and sea surface temperature, but people are also using other types of data to link with this. One of my colleagues is looking at the behaviour of fishing boats using the beacons that track their positions. And you can see where they slow down, where they start, where they finish. You can understand their fishing behaviour, and then you can relate that to these parameters. So you can understand why they might be fishing there and which areas are under the most fishing pressure. This is all really useful information for fisheries managers.
And you were at a course a couple of weeks ago at the University of Ghana.
Yes, they've been doing a lot of work on this there, some really lovely examples. They've been putting all this data and information about the behaviour and the satellite data into models so they can actually start predicting where they're likely to see fishing behaviour. They've also been using other data from the Copernicus programme to look at illegal fishing activity.
Ah, that's quite cool.
So
monitoring this kind of illegal fishing and where to start protecting stuff.
Yep.
Yeah. Katerina, if there's other things that you're interested in, particularly how to use the data, there's a really nice toolbox called Snap, and we've just put a whole range of tutorials of how to use Snap on our website. And the ocean colour one is actually done by Hayley. It's really quite nice. Hayley, it's been brilliant having you back here at EUMETSAT. It's a real privilege to have you back. I wish you well for all of your work in the future. Next week, we're going to be looking at the policy implications of what we've been looking at. How can what we've been learning here make a difference in the world, and also some of the citizen science possibilities with this kind of data. I really hope you enjoy the week and the final part of this course.